4.5, we're going to talk more about isosceles and equilateral triangles. We already know what they are at the beginning of the chapter. We said that an isosceles triangle is a triangle with two congruent sides. Remember, I saw two of these isosceles. And then an equilateral triangle is a triangle with three congruent sides. But back to your isosceles there at the top. Isosceles triangles have parts. The legs of an isosceles triangle are the congruent sides. So the two congruent sides of a triangle are called the legs. You all have two legs. Those are the congruent sides. The two congruent sides are called the legs, two legs. The non-congruent side, or the third side, is called the base. So the three sides of an isosceles triangle, you have two legs and a base. Base does not mean bottom, it just means non-congruent side. So if I have an isosceles triangle here in blue, the left side of it is actually the base, because it's the non-congruent side. Between the two congruent sides is called the vertex angle. So the legs, the two congruent sides, make the vertex angle. Opposite of each leg are called the base angles. Opposite, across from, they don't touch. Opposite of the legs are the two base angles. The base angles sit on the base. They both touch the base. The base angles touch the base. Two base angles, one vertex angle. You have a picture on the right side of those terms that they want you to label. The top one is pointing to this angle here. Would that be your base angle or your vertex angle? Vertex angle, good. The next blank down are pointing to these two sides. Is that your base or your legs? The legs. The congruent sides are the legs. The third one down is pointing to this third side, which we'll call the base. And the last one is pointing to these two angles that sit on the base. So those are called your base angles. Okay, parts of an isosceles triangle. Two legs and a base, two base angles, and a vertex angle. There are two theorems that go with isosceles triangles. The first one, the isosceles triangle theorem, states that if two sides of a triangle are congruent, then the angles opposite of them are congruent. Opposite, across from that side, does not touch that side. So in my picture here, triangle ABC is isosceles because it has two congruent sides. Since it has two congruent sides, it needs to have two congruent angles. And it's the angles that are across from that side. So which angle is across from AC? B. Which angle is across from CB? A. So these are your congruent angles. So we'll say that angle A is congruent to angle B. When you use this reason in a proof, you'll write it using this shorthand here. If two sides of a triangle are congruent, then the angles opposite of them are congruent. The isosceles triangle theorem. Its converse, the one below that, converse of the isosceles triangle theorem states, if two angles of a triangle are congruent, then the sides opposite of them are congruent. So if you have two angles in a triangle congruent, then you can conclude that the sides opposite of them are congruent. Again, this is how you'll write it in a proof. Looking at triangle ABC, I know that angle A is congruent to angle B. So the sides opposite of them have to be congruent. Which side is opposite of angle B? Yep. And how about angle A? BC. You could say CB and CA, that wouldn't change it. But since the two angles are congruent, then the two sides have to be congruent. These are theorems, properties of isosceles triangles. The definition of an isosceles triangle is that it has two congruent sides. The property then is that there are two congruent angles also. Okay, so make sure you understand the difference there. Go ahead and flip it over. we have another theorem to do that goes with isosceles triangles. This one doesn't have a name, but if you know it, it will come in very handy with your proofs in your work. It states, the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of its base. Okay, so you got to have an isosceles triangle. So if triangle ABC is isosceles, and CD bisects angle ACB. Angle ACB, that's the vertex angle. So if your vertex angle is being bisected, then you can conclude that the bisector, CD, is the perpendicular bisector of the base. What does it mean if two things are perpendicular? They make a 90-degree angle. So since the vertex angle is being bisected, I know that the bisector is perpendicular to the base. What's it mean to bisect? Cut it into half. So since the vertex angle is being bisected, the base is being bisected. So if I bisect the base, what do I know down here then? And AD is congruent to DB. Good. Oops. Congruent to DB. You proved this theorem last week. We did it together on the sideboard. It was number 5 at the top of the paper. It didn't say it in these terms, but the theorem says that if you have an isosceles triangle and the vertex angle is being bisected, then that bisector cuts the bottom in half and makes a right angle. It becomes the perpendicular bisector of the base. I don't have shorthands for that one. There's no name for it, so if you're going to use it, you'd have to write it all down. Yes, Sarah? Exactly. Yep, exactly that. Yeah, so don't get confused. This just means 90. That doesn't mean bisect also. Good. All right. 2 more. The last 2 are called corollaries. A corollary is just a rule that comes from a theorem. So without the theorem, I wouldn't get this rule. This says it's a corollary to theorem 4.3, which is on the front side. And that theorem stated that if a triangle has 2 congruent sides, then it has 2 congruent angles. This corollary, it's like a little indent underneath of that theorem, states that if a triangle is equilateral, bless you, then it's also equiangular. Bless you. What's it mean if a triangle is equilateral? All the sides are congruent. What's it mean if it's equiangular? Yeah, so we could reword that and say if a triangle has 3 congruent sides, it must also have 3 congruent angles. Okay? So they're saying since these segments are congruent, then the angles must be congruent. So angle X is congruent to angle Y, which is congruent to angle Z. If a triangle is equilateral, it's equiangular. If a triangle has 3 congruent sides, it has 3 congruent angles. Corollary to theorem 4.4. On the front, theorem 4.4 said if a triangle has 2 congruent angles, it has 2 congruent sides. So the corollary to this says that if a triangle is equiangular, then it's equilateral. Or if a triangle has 3 congruent angles, it also has 3 congruent sides. So we would say that XY is congruent to XZ, which is congruent to ZY. Those 4 theorems, or 2 theorems in corollary, you kind of sum it up and say, however many angles are congruent in a triangle, that's how many sides are going to be congruent and vice versa. If it has 2 sides the same, it's going to have 2 angles the same. If it has 3 angles the same, it's going to have 3 sides the same. So those should always match up. Okay. Flip it over. We're going to go to the examples. Our first example is a proof. So you'll have a couple proofs, but then from there, it's mostly application, applying the theorems. So what's our first step in our proof? Given. Good. Write that down. M parallel to N. How do we mark parallel lines? The little feathers, yeah, or triangles, whichever one you like more. And then angle XAB congruent to angle C. They already have that marked. We're trying to prove that triangle ABC is an isosceles triangle. Vaguely, what's that mean if a triangle is isosceles? Good, it has to have two congruent sides, two equal lengths. So ultimately, we're trying to prove that two sides of the triangle are the same. And so that's why we have to think. We got to get to saying that two sides are congruent. But all they give me information about are angles. So what can I do with that? Why? Good. Branson? Angle ABC, that'd be this guy, is congruent to XAB. Why do you say that? You guys agree with him? Good. Angle ABC is congruent to angle XAB if lines are parallel, alternate interior angles are congruent. Awesome. So looking at my statements, steps 1 and 2, XAB is congruent to C, and XAB is congruent to ABC. So what do I know about C and ABC? They're congruent. They're both congruent to XAB. So for step 3 then, we can say that angle C is congruent to angle ABC by what? Substitution. You could also use transitive here because they both are congruent to the same thing, so you can eliminate that middleman. So we know then that angle B inside of the triangle and angle C inside of the triangle are congruent to each other. Sarah? Yeah, if a triangle has two congruent angles, then it's got to have two congruent sides. Remember, it's the sides that are opposite of those angles. So which two sides of my triangle are congruent? AB and CA. Good. So for 4, we'll say that segment AB is congruent to segment AC, and that's because if two angles are congruent, then two sides are congruent. Wiggly, do we have an isosceles triangle? Sure we do, because we got two congruent sides, right? Okay, so step 5, triangle ABC is isosceles. And our reason for that is the definition of an isosceles triangle, two congruent sides. There's an example of how you would use that theorem in a proof. Questions on that one? Okay, we're going to skip number 2 and we're going to go down to number 3 then. Number 3 says, suppose that the measure of angle L is equal to y. Find the values of x and y. I mistyped it on your picture though. You're going to have to cross off your y and put it down by angle L. Sorry, put it in the wrong spot. And what was at y is supposed to be 42.5 degrees. What do you think? Anybody have any ideas or thoughts? Solutions, answers? I have 3 different triangles in that picture. You know a lot about triangles. Why? How do you know they're congruent? You're missing, what else? Do you know something else? Perfect, good, I'm gonna use that. Sarah was saying, well, this guy would have to be 42.5 because they're marked congruent to each other. And then wouldn't this one have to be x, that's adjacent to it, and n be y? And I said, why? And she said, because the triangles are congruent. Both triangles use MO, so it'd be congruent to itself. So then the left triangle is congruent to the right triangle by which of our 4 reasons? Good, side angle side. So then all corresponding parts are congruent using CPCTC. So I know that the one adjacent to x is also x and the other side is y. How can I use that then to find the values of x and y? What? Which ones have to equal 180? What do you mean? Just x and y? Okay, good, because I have 2 little triangles. Jack, using my triangle sum theorem, would you agree with Cheyenne that x plus y plus 42.5 has to add up to 180? Okay, can I solve that though? I mean, I'll get x plus y equals 1 something. Why does x equal 90? You guys agree with him? Does it have to say that it's getting bisected? Well, I need to know that the vertex angle. Okay, good. The vertex angle, angle M, see the big triangle, LMN, it's isosceles. It has 2 congruent sides. So the vertex angle is being bisected, and that theorem on the top of the previous page says that if the vertex angle is being bisected, then this guy, MO, is the perpendicular bisector of the base. So I would know that. So then x would have to be 90. Good. That's using today's theorem. Then, Jack, couldn't I use that in Cheyenne's equation to find y? I could say that 90 plus y plus 42.5 equals 180, right? Oh gosh. 132.5 plus y equals 180. I got 47.5. Okay. Good. So there we used a combination of proving 2 triangles are congruent by side angle side, then CPCTC to put the x's and the y's where they go, triangle sum theorem, all 3 angles add up to 180, and then today's theorem. You could have also said x plus x has to equal what? What do those 2 angles have to add up to? 180. They form a straight line. So could we have gotten to x equaling 90 from that point? Yeah. Okay. You have so many ways now to find angle measures in triangles. Because you can use congruent triangles. You can use isosceles triangles. You can use equilateral triangles. Triangle sum theorem. All different ways. You may all come up with the same answer differently. The next 3, 4, 5, and 6, they use the same picture, but the information changes each time, so we're going to have to erase our labeling. So for number 4, says if the measure of angle BAC is 38. BAC, so that's this whole top angle, 38 degrees. Find the measure of angle C, I'm going to call it X. What can we do to find the measure of angle X? Do you need to go to the office? Are you guys sick? Do you feel ill?
No.
Okay, can you sit up and take the notes, please?
I
Thanks. Unless you need to go to the office because you're ill, I understand. But if you're not ill. You want to come up with an idea or an answer? Look at the big triangle. Triangle ABC. Jack? I don't know. Does it say that it's getting bisected? It is the vertex angle, but does it say there's a bisector? Then I can't assume that. nor did it tell me that those two angles at the top were congruent. So that's when I can't assume it. But on that previous one, Jack, they told us the top two were congruent, so then I knew it was a bisector. Good thought. Yeah, I don't know if that one will help on this one. Look at the big triangle, big triangle. Ben, do you see the big triangle? What kind of triangle is it? How do you know that? Two congruent sides, which means it has to have what? Two congruent. Yeah, which two angles of the big triangle are going to be congruent? Okay, well, this is the isosceles one, and the theorem says that it's the angles opposite of the sides. So which angle is across from AB? Which angle doesn't touch this side? Good. And how about which angle is opposite of AC? Yeah, so these two angles have to be congruent. And I know that the top angle is 38, so what can I do to find the measure of angle C then? Yeah, use your triangle sum theorem. All three angles have to add up to 180. X plus x, there's your two x's. Oh boy. 2x equals 142. Divide both sides by 2, and what do we get? 71. Isosceles triangle. Okay. C is 71, B is 71, and A is 38. How would you classify that triangle based on its angle measures? Acute. Good. They're all less than 90. 71, 71, 38. Cool. Number 5. No, you can't assume that it's being bisected. Sometimes it works out, but not always. Okay. Number 5. If the measure of angle BAM equals the measure of angle CAM, which equals 23. So these two angles are equal to each other, and they both equal 23. That's what that sentence says. BAM, no, it's individually. Good question. BAM and CAM, that's the two top angles, are congruent, and they're each 23 degrees. We need to find the measure of BMA. That's that guy down there. How do you know that so fast? Good. So now I know it's an isosceles triangle, ABC. That guy's not changing. Since these top two angles are congruent, then I know there's a bisector. So this is all new information. So since these two angles are congruent, AM is bisecting BAC, therefore it becomes the perpendicular bisector of the base. So then I know that BMA is 90 degrees. That's when you know the vertex angle is being bisected. If you don't like that theorem, that's fine. You don't have to use it. They just work as shortcuts. The right side is 23. The left side is 23. What would this entire angle up here have to be then? 46 degrees. It's isosceles, so these two angles down here would have to be congruent. So you could do the same thing we did on number 4. 180 minus 46, 134, divided by 2. What is that? 68? No. 67? Yes. Each of these would be 67. And then you can use your triangle sum theorem again. 23 plus 67 plus x would equal 180. So you don't have to know that theorem. You would just have to use isosceles triangles in the triangle sum theorem a couple times. Okay, last one. If the measure of angle B equals 3x, and the measure of angle BAC, so that's the whole top angle, 2x minus 20, find the value of x. Sarah? Where would you want to plug that x in at? Where are you putting it at? Like right here? Well, 2x minus 20 is this whole thing. It's not just this guy, though. Do you know what I'm saying? Okay. But I like your thought process so far. Why is B congruent to C? Yeah, the big triangle is isosceles, two congruent sides, two congruent angles. So then C would have to be 3x. Then all three angles inside the big triangle add up to 180. 3 plus 3 is 6, plus 2 more, so 8x minus 20 equals 180. How do I bring my 20 over? Add it, good. So then I would get 8x equals 200. Divide by 8, and you should get x equal 25. Let's double check. What's 3 times 25? What's 2 times 25? Minus 20. Okay, what's 75 plus 75? Plus 30. Okay, it works. You can plug these in and check them. If you need to, redraw your picture and don't put line AM in there if that's confusing you. They don't include either of those tiny angles, then you don't need that line. Just get rid of it then. We have 3 left. Flip it over. Try to make sure you're prepared for your homework. We've defined the values of x and y in this diagram. X is an angle down here. It's got the degree, and then y is this side length on the outside. We have 3 triangles in this picture. I'm going to start at the top one. 2 angles are congruent, which means I should have 2 congruent what? Sides. The ones that are opposite of it. So opposite of this top angle is this guy. Opposite of the bottom angle would be this one. So it's an isosceles triangle. Morgan, the vertex angle is 60. So how much is left over for those two? 120, but they're congruent. So what's the measure of each of them? Good. Using the triangle sum theorem, we know that these 2 angles have to be 60. Well, our isosceles triangle just turned into what? Equiangular, which means it's also equilateral. So now all 3 sides are congruent. To the middle guy. These 2 sides are congruent. So if a triangle has 2 congruent sides, it also has 2 congruent. Which 2 in the middle triangle are congruent? The ones that are opposite, so x in the blank one. Morgan, the vertex angle is 60. What's left over for these 2? But they're congruent. Good. So our isosceles triangle just became what? Equiangular, which means it's also equilateral. And x is 60 here, so there's that answer. And then down to the last one. 2 congruent angles means you have 2 congruent sides. Isosceles triangle with a vertex angle of 60 means the base angles are 60. Therefore, it's equiangular, which makes it equilateral. Y is representing this length. Right, so what's the length of this side? See that? Together, these 2 are 18. So they're congruent. 18 divided by 2 gives me 9. So each sides of our triangle are 9. 60 are the angles. Your side lengths will change around. It's mostly things like the application when solving them. We have 2 left. Number 5. This one you have really similar to on your homework today. A, B, C, D, E, F is a regular hexagon. Find the measure of angle BAC. Okay, regular hexagon goes back to last chapter. Hexagon, we know that's 6 sides. What does it mean if a polygon is regular? What are all the same? Good, so mark that on your picture. That all 6 sides of the hexagon are congruent and all 6 angles of the hexagon are congruent. That's what the regular part means. Find the measure of angle BAC. That's this little sliver there that I have in blue. Have any thoughts? Ideas? Sarah? Start again. Wouldn't what be congruent to what? Is, though, this angle B congruent to this angle in the triangle or the whole thing? Right. And when you use the whole thing and I put that line in there, I'm cutting it. I would need like the blue angle, angle B, and this angle to all be the same. Then that would make it equilateral. Good thoughts. Jack. Do this thing to get all the angle measures. Okay, so 6 minus 2 is 4. 4 times 180, 720. So all 6 angles inside of the hexagon have to add up to 720, right? Good. $720 divided by 6? Why? To get each of the angles? I think that's a good idea. What's 720 divided by 6? 120. So each of these black congruent angles are all 120. I'm just going to label one of them, but since I marked them, then we know all of them are 120. But I got to figure out what that little blue one is. $60 left over for what? But 60 left over from what? Good. Triangle ABC has to add up to 180, all 3 angles. AB is congruent to BC, so if a triangle has 2 congruent sides, it also has to have what? 2 congruent angles. In this case, it's going to be the blue one we're trying to find and the other guy. So when I use my triangle sum theorem, 180 minus 120, Jack said that gives us 60 left over. Together, these guys are 60, but they're congruent, so divide it by 2, and you get the measure of angle BAC to equal 30 degrees. So we use polygon angle sum theorem, triangle angle sum theorem, and isosceles triangles. Rashid, 120, 30, 30. How would you classify that based on angles? Obtuse, good. All right, last one, number 6. Suppose that the measure of angle L is 63 degrees. Find X and Y. One way here you could do this, if you look at just the big triangle, 2 congruent sides means there's 2 congruent angles, so those both would be 63. 126, 180 minus 126, 54. So this whole angle up here is 54 degrees. Now if I take that and put it back over here, what's happening to that whole angle? It's being cut in half. So if this whole thing is 54, what's each half? 27. And then you could use that this one is 27, or excuse me, that we know that n is 63, so 27, 63, and x have to add up to what? 180. Or you could use today's theorem that says if the vertex angle is being bisected, then that becomes the perpendicular bisector of the base, and you can say that x is 90 right away also. Y was supposed to be just the sliver.
So 90 plus 63
is 153.
Oh,
All right. Questions? Okay, you have multiple ways that you can solve these, you guys. Triangle sum theorem, isosceles triangles, equilateral triangles, congruent triangles. Here's your homework.